Here we are with lesson 28. In this lesson, we continue our work with algebraic fractions to include adding them and subtracting them. Today's demo is long. Sorry about that. So here's the first example. We're going to recall how we add and subtract fractions with like denominators. 2/5 plus, 2/3 plus 5/3. What is that? It is 7/3, but I just want to go in slow motion here. The reason it's 7 is that the 2 plus 5 get smushed together on the top, and the 3 gets copied, right? It's not 7/6. That common denominator just gets copied, and we get 7/3. Same thing is going to happen with subtraction, and we'll do the same kind of thing here now that we have algebraic fractions, that is, fractions with x's floating around. So let's try this guy right here. What do we like about this problem? The denominators are the same, right? We're going to have to handle them when they're different, but the easiest case is when they're the same. And in this case, what's the new denominator when I smush together to make one fraction? 3x plus 4, right? It does not change, just like the denominators of 3 just got copied into a single 3. So it's not double this, it's not that squared, it's just that, 3x plus 4. Okay, upstairs, I'm going to take my time here. I encourage you to do the same. I'm just going to copy 9x squared minus x minus, that's the big subtraction between the fractions, 3x squared minus 9x. Equals, go ahead and copy the denominator. Okay, don't copy this because it's wrong. 9x squared minus 3x squared is 6x squared. Minus x minus 9x is minus 10x. Yes? That is wrong. Looks right, but it's wrong. We made a very easy mistake to make. Anybody see it? Jake? Yeah. This subtraction sign is saying subtract everything that follows. And so I'm imagining that 3x squared minus 9x is just a bag of stuff that is all getting subtracted. But we did not subtract the entire thing. So to do this right, I highly recommend that when you smush together two fractions into a single fraction, that you put parentheses around those original numerators. So I'll do this in 2 steps instead of 1. So now I'm going to just take my time and get rid of those parentheses. The first parentheses we didn't really need, but the second one we did. Minus 3x squared, and then that subtract negative 9x becomes plus 9x. There we go. Now we're going to get it right. So 9x squared minus 3x squared, that's still 6x squared, minus x plus 9x now is plus 8x. Questions on that? So adding fractions, we're really happy if they have the same denominator, but take your time, throw parentheses in, you might need them. Okay, so this answer is fine, but to be honest, it's not complete. Suppose that you gave me something like this, 21/14 was the result of some addition. You wouldn't leave it like that, right? What would you do? You'd find what they have in common and you'd cancel, right? In this case, what does this reduce to? 3/2 by getting rid of the common factor. So this is what we talked about last class, is one of the things anyway. And I know it was a while ago because it was before our test, but we talked about how to simplify things like this. So quite tempting to cancel, for example, 8 and 4. Can I do it? No. Can I cancel maybe one of these x's from the x squared with that x right there? No, because the only operation that allows us to cancel is what? Multiplication. And these are additions. So we cannot cancel there, but we remember from way back when, our last class before the test, that we can turn all of these additions into multiplications by factoring. And so that's what we're going to do. 3x plus 4 on the bottom, there's nothing to factor. I'm just going to copy it. But upstairs, there's a greatest common factor other than 1. What is it? 2 and also x. What's left? 3x plus 4, right? factoring out the GCF. And now what can we cancel? The 3x plus 4 cancels entirely with the 3x plus 4, and that's okay because the operation upstairs was multiplication. And so our final answer here is 2x. And so, you know, like these two things are equal, but which one would you rather deal with? We'd rather deal with the 2x. Sure, a whole lot simpler. So that's why we simplify these fractions. As a rule, just like you know not to leave 21 over 14, you look to see if you can simplify. You got to start looking to see if you can simplify these fractions with x's. Questions on that? Okay. Now, we're going to complicate things much more by talking about adding and subtracting fractions with unlike denominators. So again, we're going to review how it works with regular numerical fractions, and then we'll handle the ones with x's in them. Okay, a quick example that isn't up here. Suppose that I gave you some fraction over 6 and some fraction over 5. And I said, you know, we're going to add these two. What's the lowest common denominator? It's 30, right? Just 6 times 5 is the best we can do. Okay, now suppose it's 6 and 15. Now 6 times 15 works, it's 90, but that isn't the lowest one. What's the lowest common denominator here? It's still 30, right? And so you might not really be fully aware of what you're doing to come up with 30. Like you have the numbers 6 and 15, you're doing some number crunching in your head, coming up with the number 30 because that's the smallest thing they both go into. So here's the difficulty. It's easy with 6 and 15, they're pretty small. I can kind of keep a running track of like the multiples of 6 and the multiples of 15 and see 30 is the first thing that's in both lists. But if you give me 3 numbers, and in particular 3 numbers that are kind of big, 28, 40, and 42. Anybody know what the lowest common denominator is for those 3? I don't either. This is a hard problem, isn't it? To find the lowest common denominator. We could find a common denominator by just multiplying those 3 beasts together. We'll get some massive number, but it's not going to be the lowest one. And I'm going to give you guys a process to find the lowest one. And this process is going to help us when we're introduced to x's on the very next problem, okay? All right, so here's what we do. We take the fractions, the denominators at least, and we factor them completely into primes. That is to say, factor them as far as you can go. So 28 is 4 times 7, but 4 is not a prime, so we split 4 into 2 times 2. So everybody buys, so we'll use the different color highlighters here. So 28 is 2 times 2 times 7, yes? That's as far as we can go with 28. Notice that we've just left some blank space here. We're going to be filling that blank space in a moment. And then we go to 40. So 40 is equal to what times what? 2 times 2 times 2 times 5. And it's okay if you can't get there in one shot, but you say, oh, 40 is really like 2 times 20. 2 is good. 20 is really 2 times 10. We got another 2, and 10 is really 2 times 5. You just make a factor tree or some way to get down to the prime factors. So 40 is that. And then the last one, 42, my first reaction for that one is 6 times 7. And I change the 6 into 2 times 3. So 2 times 3 times 7. Good? Okay, here's the goal. The goal is to make these denominators all the same. The only thing that you have, the only tool that you have to change these denominators is to multiply the top and bottom by the same number. What was our funny acronym or made up word for multiplying by the same number, top and bottom? Foo-foo, fancy form of 1. So for example, if I felt like it, I could multiply the top and bottom by 10, and that doesn't change anything. Agree? It's the only thing I'm allowed to do with these fractions. What I am not allowed to do is add 10 to the top and the bottom. That changes the value of the fraction. Multiplying top and bottom by 10 doesn't change the value of the fraction. But that's just about the only thing I can do. So let's just focus on the first 2 denominators, yellow and blue. We'll come back to green after. We're trying to make these denominators the same. I'm going to complete them by looking at what they are missing. So look at this first denominator. It's got a 2 and a 2 and a 7. Look at the second denominator. what does the first denominator need so that it has everything in the second denominator? It needs a 5, and it also needs another 2, right? It's only got two 2's, but we need 3. So that's what we're going to put in. So everybody right here, write in times 2, top and bottom, and times 5, top and bottom. Now let's look at the blue denominator and ask what we need to complete it to what yellow has. So yellow had 2, 2, and 7. Which one of those is blue missing? 7. So let's give blue a 7. But whatever you give the bottom, gotta also give the top. Now look at those two denominators, the first two denominators. Things are in a different order, but what do you notice about those two denominators? They're exactly the same. They both have 3 2's and a 5 and a 7. Agree? And that we built it with just this methodical process by filling in what's missing. Okay, time to bring in the last piece of the puzzle. That's green. I'm going to first build up the first two denominators to anything they're missing. What does green have that these guys don't have yet? There's a 3. Green has a 2. They've both got plenty of 2's. We don't need any more 2's. We don't have a 3 yet, so we're going to give both of those a 3. 7, yep, 7 is already in both. So we're just going to multiply by 3, top and bottom, in the first two fractions. Okay, I think our first two denominators are good to go. It's just a matter of building up the last one. The last one only has 2, 3, and 7. It needs everything from the first two denominators. So how many more 2's does it need? It needs 2 more 2's. So we're going to multiply by 2 and by 2, top and bottom. So the new denominator down here now has 3 2's. That's what it needs. It's got a 3 and it's got a 7. What doesn't it have that is the 5? So multiply by 5 there and 5 there. And so with all of that work, you should see that these three denominators are now exactly the same. They all have 3 2's and a 3 and a 5 and a 7. Somebody with a calculator, can you just multiply that just to one of those denominators together, just so we have a number? 2 times 2 times 2 times 3 times 5 times 7. And while we're waiting on that, I'm just going to copy this denominator now once. What is it, 840? Thank you. So 840 is the lowest common denominator of 28 and 40 and 42. That is not something that I could just do by looking at it in the same way that I can look at 6 and 15 and say, oh, 30, right? 840 is the lowest one. Okay, we're copying any one of those denominators. They're all the same. In fact, sorry, let's scratch that. Let's multiply out upstairs. 9 times 2 is 18, times 5 is 90. Am I doing that right? Yep, 90, and then times 3 is 270. So this first fraction is a 270. I'm going to be a little bit lazy. You guys can be a little bit lazy here too. I'm just going to write LCD for lowest common denominator. It's true it's 840, but I actually just illustrated the 840 so that we would know that we've got the same denominator downstairs and what that number was, but I never actually intend to multiply out on the bottom. Minus, okay, my middle fraction, 3 times 7 is 21, times 3 is 63, divided by the lowest common denominator. Last fraction, also minus 1 times 2 times 2 times 5, that's 20, over the lowest common denominator. Yeah? Okay, I'm going to jump down to some blank space here. I need somebody to help me with those numbers. 270, 63, and 20. 270, 63, and 20, and they were both minuses, right? Okay. So 187, you said? Okay, so that is that. So we've combined all the stuff on the top. And so what do I want to do here? At this stage, I'm going to bring our denominator back. So I think we had 3 2's and a 3 and a 5 and a 7. And again, I'm being very particular about not ever multiplying out on the bottom. So that's our answer, but what's the last thing we need to just look for to make sure it's Finished. See if we can reduce, right? Maybe there's some common factor. So 187, we might not happen to know what that is in primes, but with a calculator you could get there pretty quick. 187, anybody happen to know a number that goes into 187?
Right now, 15 bucks.
17 goes into this number. 17 goes in 11 times. So I'm going to copy the bottom just as it is. And I'm going to ask if there's anything that we can reduce. Can we reduce anything? No. Because there are no numbers that are the same, and we're all the way down to primes. So there's nothing else to do, but I'll just say if we had decided to multiply out, I think somebody told us it was 840. Do you see that to determine that we can't cancel anything, we would just have to go back to the primes anyway? Like, it's easy to tell that nothing cancels when you're in primes, when you're factored. Whereas with 840, we would have to just refactor it again. That's why we never multiply out on the bottom. So let's leave that guy just as it is. There. And so I think our final answer, because these are just numerical things on the next page, we've just got a plain number on top and a number on the bottom. So that's what we get when we do all the addition and subtraction for these three fractions. Okay, so that was the easy part because that was with numbers. And then we get to the harder part with variables in it. So three fractions, we've got some addition, we've got some subtraction. What's the difficulty with these three fractions? What makes this a harder problem than the denominators are different, right? That's really a shame because we have to do work to make them the same. So how do we make them the same? Well, two choices. There's the good way and then there's the really bad way, which might be technically correct, but will probably put you in a place where you can't get to the simplified final answer. The bad way is to just say, okay, I'm just going to multiply those three denominators together. And that is a common denominator. That is not the lowest one. And it's a really bad place to go. So better is to factor all of the denominators first, just like we factored 28 and 40 and 42. So we're going to factor x squared plus 4x. What's the greatest common factor? X. And we're left with x plus 4. So we're just going to, circle right here. X plus 4. There it is. The next one, we'll go different color. This guy right here, the greatest common factor is 1, so that's not helpful. This is a 2x2 box problem. Again, we're not going to take our time, but in your own time, I trust you guys could get down to that from the 2x2 box, okay? And then the last one is 2x. Nothing to do with that. It's already factored 2x. So those are our three denominators, but notice that we factored first. Also notice that we put some blank space. We're going to be filling in some things to make these denominators all equal. Okay, let's look at the first two denominators, blue and green. What is this first one missing that the second one has? X minus 3. That's what it's missing, right? It's already got an x plus 4, so we don't need another x plus 4, but we need that x minus 3. So that's the first thing we put in here. Times x minus 3. But you can't go around multiplying the denominator of a fraction without immediately multiplying the numerator. So x minus 3 on top and bottom, that is our foo-foo. And now we look at the second denominator. What does it need to become the first denominator? It needs that x that's in the front. So we're going to multiply by x here. I'll throw it in parentheses. And x here. The twist on this guy is that all of a sudden I need parentheses that I didn't have before. It's really easy to miss that, right? That x is multiplied by the entire numerator. It might be a good idea just as a rule to put parentheses around all of your numerators anyway. Some of them you won't need, but in the ones that you do need, if you don't have them, you're going to get the problem wrong. Okay, what do we notice about those new first two denominators now? They're the same, x plus 4, x minus 3 in some order. Okay, now we look at the last denominator. I see 2x. what does this first denominator need that the last denominator has? Does it need a 2x? This is a 2 times x. That first denominator already has the x. It doesn't need an x squared. It just needs the 2, right? You know, I mean, look, imagine if you just put a 2 there, all of a sudden, there's your 2x. Yes, it's got what it needs. So it just needs the 2. So we're going to multiply top and bottom by 2. The middle denominator, what does it need from the last denominator? Also the 2. And in fact, if you've made the first two denominators the same at this point, then they will both need exactly the same thing from that last denominator, whatever that same thing is. So times 2, top and bottom in the middle fraction. And now the last fraction is quite lonely right now. It needs a lot of stuff. We've got to build to those two other denominators. So what does this last guy need? X plus 4, and also x minus 3. And so we give both, all in parentheses. Okay, what do we notice about these three denominators? They should be all the same. Different orders, but should be exactly the same things. They all have a 2 and an x plus 4 and an x minus 3. And so that means that we can smush all of these fractions into one. Again, I'm going to be lazy and you can do the same. We've just got our common denominator. Now that it's all the same, we can do this. And I'm just copying everything up on top. 3x minus 3 times 2 minus, that's the big subtraction, 5x minus 1 times x times 2 plus, and then copy these last three. You can keep LCD there. I just want to put this in to show you one common pitfall. Okay, take a look at this x minus 3 right here. It's on the top. There's an x minus 3 on the bottom, so I can cancel them, yes? Can we cancel those x minus 3s?
We should,
Why can't we?
because then it removes the.
It's not just multiplication. Yeah, a couple of things going on here. So number one, even though it looks like there's multiplication locally in there, this is a subtraction and also an addition up on the top. So you can't just cancel those. Furthermore, if you do cancel, for example here, like you could cancel the x minus 3s there. That's just in one fraction. But if you do that, you're going the wrong way. You're going back to the original problem. And as Lennon says, we're losing the common denominator that we worked so hard to build. You'll always have that opportunity to cancel, but don't. You put that x minus 3 in the bottom for a reason. Okay, so we are here, and we still have some work to do. So what we're going to do is distribute up on the top. Let's try that now. So I'm just going to imagine the 2 times 3 is 6, and then I'm distributing that into the parentheses. So 6x minus 18, we buy that? Minus. Okay, and now I'm looking here. I'm just imagining that's a 2x in my head, which will distribute into the parentheses. So 2x distributing in here and here. What do we get? 10x squared minus 2x. Okay, the last one is the toughest one because the last one is 3 binomials multiplied together. We're going to do this in 2 steps. I don't have a shortcut to do it in one. So we are going to just do these first 2, foil or lobster claw or box, and then we're going to multiply whatever we get by the last one. I'm going to do this off on the side in a different color. So I'm going to circle in purple these 2 right here. which we're going to put over here. So distributing over there, what do we get? 1 times x, 1 times 4. That's x plus 4. Plus, now we're going to bring the x in. X squared plus 4x. Yeah? Everybody see where we got that? Foil or lobster claw or box. Okay, combining like terms, and how about we just write this in our standard order, which is the x squared first, and then 5x, and finally the plus 4. So the circled purple things are all the same. And so let's go orange here. This thing is really just the purple thing times another x minus 3. We're going to write that over here in the box. So we've got the purple thing multiplied by x minus 3. Okay, so this is a bigger lobster claw. Foil is no longer useful. So either a lobster claw or another box. I'll draw the lobster claw here. So this x squared is going to come in and hit both. The 5x is going to come in and hit both. And then the 4 is going to come in and hit both. Kind of like a mutant lobster claw with 3 prongs. Okay, so just carefully keeping track of everything. So the x squared times everybody gives what? X cubed minus, it's a negative 3, yeah? Not 15, right? The 15 will come here, yeah. So x squared minus x cubed minus 3x squared. Okay, now we're doing the 5x times everybody. So 5x times x is plus 5x squared, and then 5x times minus 3, that's the minus 15x. And then finally 4 distributing in, so 4x minus 12. Okay, so just keeping track of equal things here. Orange box again, and one last orange box will be our final simplified version of this thing. X cubed doesn't partner with anyone. How many x squareds? Plus 2x squared. How many x's? Minus 11x. Minus 12 doesn't have a partner. So that orange box is here. And so we're just going to copy it right in there as it is. X cubed plus 2x squared minus 11x minus 12. Okay, and finally I missed one symbol. It was this plus sign right here. There. And then I'm just going to abbreviate LCD, lowest common denominator, on the bottom. See, you guys never thought you'd get to a point where you just missed ordinary fractions, right? Like you yearn for the days of just having to do ordinary fractions. Okay, so despite all of our efforts there, this one's almost done. But actually, we've made a mistake up here. And again, it's a really easy mistake to make. This original problem involves subtraction, yes? The original problem, go way back to the beginning. If there is subtraction floating around, you got to be really careful that you are subtracting the entire fraction, and we did not do that. So just to be clear, let's go blue here. The first 3, eventually got expanded to the 6x minus 18. The next term was a 5x minus 1. That got expanded to this, and it's those parentheses right there that we need, because we need to subtract the entire thing. Because the next symbol is a plus, it actually doesn't matter to have these ones, but I'll put it just to be clear. So you should always have parentheses around your 3 new numerators, and that way you won't go wrong. Okay, so let's collect like terms, and I think this one will be good. I like to have my highest power first. So what's the highest power you see anywhere? X cubed, and are there any others that combine with that one? That's the only one, so I'm content to write x cubed first. I'm going to put a little check mark so that I know which ones I've done. Okay, next ones we're looking for are x squareds. So I see a 10x squared here and a 2x squared there. So plus 12x squared. No, it's, yeah, that 10 is negative, and you got to be really careful. It's negative 10x squared plus 2x squared is negative 8x squared. There we go. Okay, next one, we actually have 3 terms here. So we're looking for just the x's. I've got the 6x, I've got the negative 2x, but it is in disguise. That's really a plus 2x. 6x plus 2x minus 11x. What is that? Six x plus 2x minus 11 is minus 3x. Thank you. Okay, and then the last terms are just the constants. Minus 18, minus another 12. Nobody's in disguise. That's minus 30. Okay, because this is going to be our final answer, this is the time where I don't want you to put LCD. I need the final answer to have x's in it, not abbreviations. So we're just going to copy our factored version from 2 lines above. Just like that. Okay, a couple of things about this one before we move on to our last one in the activity. Number 1, this is hard. I know it's hard, but everything's hard the first time you see it. So be patient with yourselves. Don't get too distracted by the massive multiplication. That did take a bunch of our time here, but there's nothing new in there, right? The new stuff is all the fraction stuff. I could have asked you to multiply those things on the first day of the semester, and you would have been able to do it in time. Number 2, technically, it is our obligation to simplify our final answer as far as possible. Now, the only way to simplify is to find multiplication, and currently, the bottom is all multiplied, but the top has additions and subtractions. So, for example, I'm not allowed to cancel that x and that x, right? Because the top has additions and subtractions. And so the way that we would handle that would be to factor the top. What is the greatest common factor of all the terms on top? It's just 1, which isn't helpful, right? There's nothing other than 1 that goes into all of them. And we have no other techniques for factoring things with x cubed in them. The only technique we have for that power or higher is factoring out the greatest common factor. If this had been an x squared at the start, or for example, if we just didn't have this thing at all, then we'd have to try our 2x2 box to factor that thing on the top, right? And maybe, just maybe, something will cancel in the bottom. We have to look for it. But we have no techniques for this, for anything with an x cubed or higher other than greatest common factor. So we're done. Last observation, while we do a lot of distributing upstairs, we never do any distributing downstairs. Because suppose, again, that guy wasn't there, and then suppose that this thing right here ended up factoring into like an x plus 4 and an x minus 5. I'm just making this up, don't copy it down. But just suppose we did our 2x2 box and did that, what could we cancel then? X plus 4 and x plus 4, right? But the only reason it was easy to see that that canceled was because we never distributed on the bottom. If you had distributed on the bottom, you'd have to go right back and get it into factored form, so why bother? So we always leave the bottom in factored form. Some students feel an obligation. Hey, anytime I can distribute, I must. It's not true. In the bottom, we never distribute. Upstairs, yes. Downstairs, no. Okay, I think that is that. One last example on the next page. Here we go. We're just going to look at highlights of this one because I want you guys to have lots of time to practice here. In this case, we are subtracting 2 fractions, right? We always have to factor the denominators to figure out what the lowest common denominator is. What factors out of this? X. So everybody buy x minus 1, that's correct. Okay, and then the second denominator is this guy. And I'm going to circle over here. Actually, I'm going to circle a couple of things. So the x minus 1 is just copied. You can see that. But the stuff in the front, the x squared plus 4x minus 5, that's a 2 by 2 box. You will see that you get x minus 1 times x plus 5. The only reason I'm showing this example is that what do you notice is kind of funny about this second denominator? What do you notice about those three factors? Two of them are the same, right? It has x minus 1 and x minus 1. So this example is just here because I need us to be able to handle repeated factors. So let's think about the common denominator, the lowest common denominator. Okay, here we go. Let's look at the second denominator first. What does the second denominator need that the first one has? Just the x, right? Second denominator has an x minus 1. In fact, it has two of them. So all this guy needs is an x. That necessitates parentheses around the x minus 7. Second denominator is good to go. It's the first denominator that I want to make sure we can handle. Looking at the first denominator, I see x, x minus 1. I need to complete it to the second denominator. I need to put in what's missing to build the second denominator. Okay, for sure, excuse me, for sure we're missing an x plus 5, yeah? So let's put in the x plus 5. That's definitely needed. But then the question becomes about the other x minus 1, because the first denominator has an x minus 1, but the second denominator has two of them. Are these denominators the same yet? They're not the same. So we got to add, we have to build what's missing, what is missing, another x minus 1. And so it is perfectly legitimate to have to give something another copy of what it already has. You have to do whatever it takes to make those denominators the same. And in this case, that means giving the first denominator another x minus 1. Now it has two of them, just like the second one. You can read the rest of the problem later. That's the only new thing for this problem. Okay, activities on the next page. Go ahead and get started and we'll see how far we can get. Raise a flag if you get stuck.